Once you finish mashing, you boil your wort. So once again, you need to be able to turn a boil kettle on. You need to be able to measure temperature because you need to start the timer once your liquid is actually boiling. And then we need alarms to add in hops or spices or lemon peel or vanilla beans or whatever. And then once you're done, you have to measure the temperature to know when it's cold enough to actually pump to your fermenter. Once in the fermenter, we go through the same thing. You need to be able to monitor and control the temperature quite precisely. Now, like I mentioned, too hot and you kill your yeast. Too cold and the yeast goes dormant and just doesn't ferment. But even if you're in the sweet spot where the yeast does ferment, for some yeast, fermenting at about 15 degrees Celsius will give you spice flavor. The same yeast fermenting at 25 degrees will give you fruit. So you could be aiming for a wheat beer that has spice flavor and end up with something tasting like banana bread. Now, that's fine if that's what you're going for. That's not great as a surprise. And then I'll get back to monitoring specific gravity. We get into some chemistry there, which is expensive and hard. But then we also want to log everything, because if you screw up, next time you'd like to know what went wrong and hopefully try and avoid it. So I started building this, and within about 10 minutes I ran into the first problem, which is there is no Raspberry Pi emulator. So you get to deployment time, you've created your great new project, and you have nothing to deploy it on because you haven't bought the Raspberry Pi yet, or because you're too lazy to drag it out and hook a network cable to it, and all those things. Also, working with physical sensors is hard because if you're not getting the value you expected, is it your sensor that's faulty? Is it your implementation? Is the value actually just not what you expected? Not easy to know that. And then the next two problems is not so much IoT applications as Android and general development, I guess. We end up with these activities that just implement everything. So we want to read temperature, so we stick all implementation for the temperature sensor in the activity. And I think we do that because that's what sample looks like. And by the time you realize it's a big problem, it's a really big problem. And for the same reason, behavior spreads across classes. Every time I need to read the temperature sensor, I stick part of the implementation in the activity and end up duplicating code. Luckily, Uncle Bob gave us clean architecture. Now, it's a bit hard to see how to apply this to IoT apps. You should go read his blog post on clean architecture. It's worthwhile, but I found that hexagonal architecture is a better approach for IoT apps. So it was mentioned this morning, like anything else, it can be abused. But what's really useful for Android Things projects is it allows us to separate a contract from the actual implementation. So ultimately, that allows us to run our code on an emulator and to write testable code. So, like was mentioned this morning, the hexagonal architecture has nothing to do with 6. There's no 6 anything. What it does give us is a port through which anything interacts with our application. So we want to read temperature, we have a temperature port. And that port is simply a contract saying, I'll provide the temperature when you call this method. Having that, we can take our BMP 280 sensor, build an adapter that implements that contract, and we have a working sensor. More importantly, we can build a mock sensor and add an adapter for that. So how do we implement this on Android Things? Well, the first part is to make your project runnable on an emulator. And then the second part is for each service or hardware that you need to interact with, you just create the port first, you create a mock adapter, you build some tests, you can build your UI at this stage, and then finally, once all that works, you build the real implementation. So once you've created the standard Android Things project, you simply make the Android Things dependency compile only, and that's equivalent to Maven's provided. And then you add an intent filter for a category.launcher. Now, this just tells your emulator which is going to be your main activity. You've already got a IoT launcher intent which will tell it which activity to launch on boot on the real device. And then we can start implementing our hardware. So like I said, the port is simply a contract. So for Android, that's an interface. We know it's going to be a temperature sensor. We'll want to read the temperature. And having worked with hardware, we know there's going to be some cleanup afterwards. So I added a close method. Then we built the mock adapter, which just returns a hard-coded value every time you read it. Now, you can go more complex here and increase that value every time it's read, simulating a liquid heating up. And we can build a bunch of different mocks for different scenarios. And then for the real implementation, we're not going to spend any time on this. This is the examples you find online. Basically, you need a driver, you add a listener, and the read method only returns the last value read by the actual sensor. And in the close method, you do any cleanup, unregister listener, close the driver, etc. But once you have this, you can now mock out anything. In your activity, instead of all that implementation code, you just ask for a temperature sensor. And based on some configuration, you return either the real one or some other mock. In my case, I did it based on bold types, but you could do it based on bold variants, shared preferences values, a database configuration. So in my case, for a release build, it uses the real sensor. For a debug build, I'm assuming I'm deploying to the emulator. And now you can actually test your UI. So this is just a espresso test that starts up the activity, hits the read button, and confirms that the value read in was the hard-coded value. And there you can see it running in the emulator and the test passing. Now, I'd love to tell you that I have a fully automated system and everything works, but I'd be lying. What I do have is a lot of these slices of functionality, like the temperature sensor, relays, monitoring liquid volumes. I have all these discrete pieces, but I haven't tied them all together yet. So next step is writing a pretty UI and tying it all together. And I'd love to use the Google Nearby API to essentially pair my phone with my brewing system. So when I'm busy brewing, I get push notifications on my phone rather than having to stand next to the brewing system all day. And I mentioned earlier reading specific gravity. Now that's essentially how much sugar is in your liquid. That kind of thing is really hard or really expensive to measure. You can buy an expensive sensor for, I think, about 7,500 rand. I'm not really into that. So you can get clever by, for example, floating something in the fermenter at an angle with an accelerometer in there, so that when the density changes, the angle changes, and then you can do calculations to relate that back to the actual specific gravity. So at the moment, that's where I am. More to come, but not there yet. Thank you. Now I think I can quickly sneak in one question before they cut me off.
What does the beer taste like?
Awesome.
That's JavaScript.
Not necessarily always what I intended, but you know, that's the advantage of building a system like this. Lots of testing. Yeah. Not at the moment, but, well, it will be. I just haven't gotten there yet. Yes?
How do you actually keep the temperature consistent?
During the fermentation or?
During fermentation.
Yeah, it's basically because it makes it more repeatable. If you keep the temperature consistent, you know that that beer you end up with, if you want to brew it again, you just keep it. Oh, how? I stick the fermenter in the fridge and turn the fridge on and off. Now, it's not quite that simple. You want an algorithm that doesn't constantly switch it on and off, because the fridge doesn't like that. But it's simple enough to do.